So fundamentally, it's a adsorption-desorption process where the heart of this process is a filter material which selectively captures CO2. So CO2 is a acid, and what we develop is a base, and the two like each other. So the CO2 gets captured on the surface of this material. And in a second step, we heat the material. This is why the plant sits on the roof of a waste incineration plant, where we have a lot of waste heat. And this waste heat is used to drive off the CO2 from the filter material. With this plant, we can show costs of roughly $600 per ton, which is, of course, if we compare it to a market price, very high. But if we compare it to studies which have been done previously projecting the cost of direct air capture, it's a sensation, because studies so far assume that what we do will cost $600 per ton. Like, this is a study by the American Physical Society, and one study by MIT, Stanford, and Berkeley even assumed $1,000 per ton for plants which are A, industrialized, and B, have a much bigger scale, so not 1,000 tons per year, but factor 1,000 more, so 1,000,000 tons per year. So we are very confident that once we build version 2, 3, and 4 of this plant, we will bring down costs by, so we foresee a factor 3 cost reduction in the next 3 to 5 years, so a final cost of $200 per ton. Like, the long-term target price or cost for what we do is clearly $100 per ton of CO2. Like, the vision of our company is to capture 1% of global emissions by 2025, which is super ambitious, but which is something which is feasible. Like, the plant we start to operate today features a capacity of 1,000 tons, and we would need 300,000 of such plants to capture 0.3 gigatons, which is the amount of, like, if we compare that to containers which we need to build, that's the amount of containers going through Shanghai Harbor in 2 weeks. So it seems feasible that with what we're doing, such gigaton scales can be achieved. But as mentioned before, it's really hard to say, like, what will be the exact amount of gigaton at what year. Paris says we have to go to 0 gigatons to, like, reach or be CO2 neutral in 20 to 30 years, or by 2050 actually, which requires severe emission cuts and combination of all technologies which are available. Yes, it took us 8 years to get to where we are today, but we started as college graduates. We started without any experience. We started, the two of us, Jan and myself. Today, Climeworks has 45 employees. We have more or less 8 years industry experience in direct air capture. So we feel like, given the fact that we have shown in the past, I think, the skills or the capacity to go from lab scale to industrial scale, I think we also have the experience and skills to drive this to a much larger scale. So I'm very confident that we can continue this strong growth, which we had, especially in the last 2 or 3 years, in order to meet those targets.